Hello everyone. First of all, I'm sorry I could not post any videos for last 3-4 days because of some technical glitch. But anyway, I'll cover all that, whatever is left behind. Today we are going to talk about the fifth day. That is, we'll be considering Newton's laws of motion, and we'll be discussing some problems based on Newton's laws of motion. We'll talk about mostly the previous year problems. Yeah, so let's follow. The first question. A ship of mass 3 into 10 to the power 7 kg initially at rest is pulled by a force of 5 into 10 to the power 4 Newton through a distance of 3 meter. Assuming that the resistance due to water is negligible, the speed of the ship is. So we have been given a ship, let's assume it to be some object, and it has some mass which is provided to us, and initially at rest, so U is 0, is pulled by a force of 5 into 10 to the power 4 Newton. There is a force being applied, that is 5 into 10 raised to the power 4 Newton, through a distance of 3 meter, and eventually it covers a distance of, let's say, 3 meters. It comes somewhere here. Assuming that the resistance due to water is negligible, the speed of the ship is. We need to find the speed. Okay, it was initially at rest. There is a force being applied on that. So first we need to find out the acceleration. And if the force is constant, the mass is constant, I can simply go as acceleration is equals to force per unit mass, because F is equals to ma. And if you apply A is equals to F by m, you know F, you know m, you will get A. This is the acceleration, and obviously if F and m both are constant, A is going to be constant again. So in that situation, we are supposed to find out the speed of the ship after, when it has covered some distance of 3 meter. We know the acceleration. We need to find out the speed. Can't we simply apply v square is equals to u square plus 2as? Because this result is valid if the acceleration is constant, which is here. So velocity is equals to u square plus 2 times of acceleration as. Initial velocity is 0, so this vanishes. A we have found out using F by m. Displacement is given, that is 3 meters, so I can find out v very easily. And that will be the calculation. Okay, this question has been there, it was there in IIT JEE 1980. Now you can think of, there are sometimes very easy questions comes in IIT, and it's very difficult to believe. Sometimes we think, okay, fine, there must be a trick or something like that, but whatever is given, that is what is given, right? So even if some basic formula can lead you to the answer, that's perfectly okay. The questions may be easy sometimes, they may look like difficult, they may look like tricky, but they're damn easy. It's like, it is one of the easiest question I've seen, I've come across. You just have to put the formula, you need to find the acceleration, and accordingly apply the equation of motion, and you'll get the result. Moving on to the next situation, a block of mass 2 kg rests on a rough inclined plane. When the rough thing is mentioned, that means it is a friction, the surface with friction. Rough inclined plane making an angle of 30 degree with the horizontal. Imagine that the angle is 30 degree, consider. And the mass is 2 kg. Now, this block rests. That means it has been mentioned that it is resting, it is not sliding down. What is the force which is responsible for it to slide down? If I consider, in the downward direction there is mg, and in this direction there will be normal. If I make the components, effectively it will become mg cos theta, which is mg cos 30, and this side it will become mg sin 30. So mg sin theta is responsible for the block, responsible for the movement of the block downwards. What is stopping it? Friction. And right now, if the block is at rest, that means the static friction is working, and the static friction, as you know, that it is dynamic. It depends. That means static friction is something like it changes according to the situation. That means, say for example, the maximum value of static friction can be 10 Newton, but the requirement is just 3 Newton. So static friction will not give its full capacity. It will simply apply 3 Newton to stop the object. That's it. It depends on the external force. If you must be remembering the curve, it goes like this somewhat. This is the region for the static friction, the applied force and the frictional force. The more the applied force, more will be the friction force until it reaches the limit, that is the limiting friction. Anyway, coming back, mg sin theta, and this is resting on the floor. That means whatever is the frictional force, I don't know, it must be cancelling out mg sin theta. And if it is cancelling out, you don't even have to find out frictional force, you just have to look for mg sin theta. That's it. If the block is not moving, it will be just balancing it. So mg sin theta, and mass is given to you, g is considered as the 9.8 if not mentioned, sin 30 is half, solve it, you should get the result. It should be like 2 into 9.8 into sine 30 is half. That's it. It comes out to be 9.8. This is the result. So the mu is equals to 0.7. It is just for the trick. Like, you don't even need it. They have not asked you the maximum value of the friction. They are just asking what is the frictional force acting at that particular time. So which is just balancing the mg sine theta. Anyway, moving on the next. It is a very famous question. In the arrangement shown in figure, the ends P and Q of an unstretchable string move downwards with uniform speed u. Pulleys A and B are fixed. Mass M moves upwards with the speed. We need to find out that what is the speed. Like, it's something like a pulley sort of arrangement. You're simply pulling P and Q both with same speed u. That means your hands are moving down with the same speed u. That means the change in length with respect to time, that is the speed v is equals to dx by dt, is nothing but gonna be u. And you have been asked, like, with what speed m will move up. So if we consider it, we have the situation here, and what are we gonna do? Just make the free body diagram. So it will come out to be like tension T this side, and it will effectively become T cos theta. In the same way, 1 T cos theta will come this side. So I can say that like 2T cos theta is balancing mg, but here this side it is 10. The tension T, but I don't think it is gonna be of any use. We need to find out with what speed it is moving up. So what are we going to do? Let's consider this distance as to be some x and this distance as to be some y. Let's assume. So basically what we need to find out, we need to find out dy by dt. That means with what rate y is decreasing. We need to find out that. And let's assume this to be some L. Or we can find out as like x square plus y square root. You can apply the Pythagoras theorem. And if you can write it like this way, it will be like x square plus y square is equals to nothing but L square. Let's differentiate the whole term. It's going to be like with respect to t. So d over dt, x square plus y square is equals to d over dt of L square. Now if you see, this is changing, like as the object is moving, this L will be obviously shortening, y is also decreasing, but x will always remain constant. This separation, this gap is always fixed. So d over dt of x square, because x square is constant, so this is going to be vanished as 0, but dy dt of y square is going to be 2y dy by dt is equals to d by dt of L square. Now I cannot differentiate it with like L, but the thing is that d by dt of L square, if we consider, it's going to be 2L dl by dt. And what exactly dl by dt is? dl by dt is nothing but the rate of shortening length of L with respect to time, which is nothing but u. So I can simply say is like 2y dy by dt is equals to 2L u. It gets cancelled out. I get dy by dt as ul over y. And if you check over here, ul over y, or I can write it as u over y by L. Now this is theta. This angle is theta. This is y. This is L. So this is base upon hypotenuse. I can simply say it as u over cos theta. This should be the result. This is one way. This is the proper way of solving this particular problem. There is another way. You can simply find it out. Like, you need to find the angle with which it is moving, like the speed with which this is moving. This is moving with speed, this row is moving with speed u. So can I say we have a situation like this is u and we need to find this. This is u and we need to find out something like what exactly is this going to be. So if we consider the rate here, it's going to be y x, the vector will come out to be as u cos theta, or effectively this is the hypotenuse and this we need to find out the change of rate. So it should come out to be something, let the speed of this moving up be v, and if I consider this like the situation, this is moving corresponding to this, so I can say that v, the component of this, like v cos theta, is nothing but u. V cos theta, the velocity which is in the upward direction, the component of this is basically u. So v cos theta is nothing but u, so correspondingly v will come out to be u over cos theta. But I prefer this particular method because this gives you the exact result in the following. You can simply use it as a shortcut, and it is a very famous question, so some people simply remember the result as well. Anyway, during the paddling of a bicycle, the force of friction exerted by the ground on the two wheels is such that it acts. Remember, the bicycle, in the situation of a bicycle, if I consider like there are two wheels over there, and there is some bicycle, my drawing isn't that very good, but the thing is that when you are talking about a bicycle, there is a chain which is attached to the rear wheel, and you pedal the bicycle, due to which the chain moves, and this chain basically rotates the rear wheel. This chain rotates the rear wheel. So the force which you are applying, that is being exerted on the rear wheel, not on the front wheel. So the rotation of front wheel is not because of your pedaling. The rotation of front wheel is because of the friction which is being applied because of the ground, because of the surface. So if you have a situation, like you must have faced this particular situation, that if you're on a slippery road, you pedal the bicycle, the rear wheel moves, but the front wheel remains static. Like the rear wheel rotates at the same place, but the front wheel remains static because it is not getting sufficient friction for the particular front wheel to rotate at the same time. So anyway, like here, what is happening that consider this as bicycle, and we are applying this particular force, so due to which this is going to rotate in some sort of this direction, and when it is going to rotate in this direction, that means these particles, like the particle is trying to move in this direction. So the frictional, the rolling friction, that means the wheel is going to rotate, so friction on the rear wheel will act in this particular direction, which will oppose that particular rotation in this direction, which is because of the pedaling. But if we talk about this particular wheel, there are no pedals, there is no force exerted by me here or exerted by the cyclist. Then who is going to rotate it? Like who is going to move it? When there is no force being exerted on this particular wheel, the only force which is acting is friction in the tangential direction, which can rotate it in this direction. Because if friction will act in this direction, then only the wheel will move in this direction. If the friction will act in this direction, there is no force which is going to balance it or overcome this. In that case, the wheel should rotate in this direction, but this doesn't happen, right? Two wheels of the bicycle cannot go in the opposite direction. They have to roll, or they have to rotate in the same direction. So friction will have to go in the backward direction. So for the front wheel, the friction is responsible for the rotation of the front wheel, right? For the rear wheel, the friction is opposing the rotation of the rear wheel. So for the rear wheel, friction will act in the forward direction. For the front wheel, friction will act in the backward direction, and the bicycle will go in the forward direction. So the option should be in the backward direction on the front wheel and in the forward direction on the rear wheel. Exactly correct. In the backward direction on the front wheel and in the forward direction on the rear wheel. In the forward direction on the front wheel and then the backward direction on the, no, not possible. If you consider it like in the forward direction on the front wheel, in that case the wheel will start rotating in the opposite direction, which is not possible. In the backward direction, both the front and the rear wheels, again not situation. In the forward direction, both the front and rear wheels, no. They have considered just all four situations. Anyway, moving to the next situation, a car is moving in a circular. Yeah, this question has been repeated multiple times in IIT, so you need to understand this particular thing. A car is moving in a circular horizontal track of radius 10 meter with a constant speed of 10 meter per second. A plumb bob is suspended from the roof of the car by a light rigid rod. The angle made by the rod with the vertical is. Okay, you can think of like there's a car which is moving on a horizontal track of radius. Some radius is there, like 10 meter. Assume it's some 10 meter radius, and there's a car which is moving. So when the car is moving, obviously there's going to be a centrifugal force, which is a pseudo force, which will act in that particular direction, which will be pushed like radially outward. Or roof of the car, there is a light rigid rod, and to that there is a plumb bob. A bob is suspended. The angle made by the rod with the vertical. We need to find out the angle. So think of this is the situation. This is the bob, and we have a condition that, let's say, it comes somewhere here. Now what are the forces acting on this? There is a force which is in the outward direction, which I call as pseudo force, or you can say a centrifugal force, which is nothing but mv square by r. It will be equal to that. That will be the pseudo force. There will be tension force, that the tension in the string, and obviously there is a mass mg. And right now they say that is in the stable condition. We need to find out what is the value. So if we try to balance it out, we can say that t cos theta is nothing but balancing mg, and t sin theta is going to balance ma. And the angle made by the rod with the vertical, yes, theta only we need to find out. So if we solve it out, it's going to be t cos theta is going to balance mg, and t sin theta is going to balance ma. If I divide both of these, I get tan theta is equals to a by g. And what exactly a is v square by r. That is the centrifugal force. So I can say that v square by r into g. That is tan theta. Velocity, which is given to me as 10 meters per second, so it's gonna be 100. Radius is 10. G I'm considering 10, so effectively it will come out as like 100 by 100. Tan theta comes out to be as 1, which implies that theta is nothing but 45 degrees. Perfect. This is a question JEE 94. A block of mass 0.1 kg is held against a wall applying a horizontal force of 5 Newton on the block. If the coefficient of friction between the block and the wall is 0.5, the magnitude of the friction. Same question, similar question. This is a pen, and I'm gonna hold this pen like with respect to a wall. Now, whatever force I apply, like with whatever force I push the pen, there is a certain minimum force which is required to hold this particular pen, because there is a weight mg on the pen, because of which it is going to fall. So when I'm holding it, there is a normal reaction, and because of that normal reaction there is a frictional force, but that frictional force will be just sufficient to balance out the mg, and they'll cancel out. If I apply more force, and imagine like there is more friction in the upward direction, in that case the body should move up, which doesn't happen. That means mg should just be equal to the frictional force. We are not even concerned about how much force I'm applying. If the body is resting, that means mg should balance out the friction. And if I consider the situation here, I know the mass, which is 0.1, and I know the acceleration due to gravity, assume it to be 9.8. Eventually it comes out to be 0.98, and this is the force which is acting in the downward direction of this body, mg. And this should be balanced by the friction. They're asking the magnitude of the frictional force acting. That should be 0.98 Newton. That's it. No change. We need to be concerned about the static friction only when the object is at the verge of motion or is in the motion. Then only we can see the variation. Otherwise, it is just going to. Then only we are going to need that mu thing, coefficient of friction. Otherwise, it's just like it's balancing the other force. That's it. Moving to the next question, an insect crawls up a hemispherical surface very slowly. The coefficient of friction between the insect and the surface is 1/3. If the line joining the center of the hemispherical surface to the insect makes an angle alpha with the vertical, the maximum possible value of alpha is given by. Cool. We have a situation here that there is an insect. This insect is trying to crawl over this particular hemispherical bowl or surface. Then what happens that when it is somewhere here, we need to find out like how much further it can go. Because after some time the gravitational pull will pull it down and it will slip down. So there is some frictional force on the surface, and the question has been asked like till what angle it can move. We need to find out. So basically at that time friction will be at its verge, friction will be maximum, and that limiting friction will be balancing the force due to which it is gonna come down. So let's assume that it is making the same angle alpha only. I'm making the free body diagram here only. Let's say the force downward is mg, whatever it is. This will be mg cos alpha. There will be a normal reaction in this direction, and there will be a force mg sin alpha. I made the components of mg, and there will be this frictional force. Now this friction will be maximum when it is equal to be mu s n. Mu s is coefficient of static friction into n. And n, because there is no vertical motion, so n is going to balance mg cos theta. So I can simply say that it is going to be mu s mg cos theta. This is the maximum frictional force, and it should balance out, not exactly theta, it's alpha. It should balance out mg sin alpha. So mu s mg cos alpha should balance out mg sin alpha. Mg would get cancelled out. I'm gonna get tan alpha is equals to mu s, which is 1/3, as the question says. So tan alpha is gonna be 1/3, the maximum possible value. We have no relation as tan alpha equal to 1/3, so I can say cot alpha is equals to 3. This should be the relation. A. Yeah, it cannot go any further angle than this particular value of alpha. The pulleys and strings shown in figure this are smooth. Smooth, that means there's no friction and of negligible mass. The pulleys have no mass and the string also doesn't have any mass. For the system to remain in equilibrium, the angle theta should be, okay, they want the particular system to be in equilibrium. That means there shouldn't be any motion at all of any object. Okay, let's make the free body diagrams. Let's, in the downward direction there will be mg, there will be some tension T. In the same way there is mg and there will be tension T. If they are not moving, then mg should balance out T. That means T should balance out mg. The tension will remain same in the string because string is light, one thing, and there is no mass of the pulley also. So it's going to be same. If it is the string with mass, we need to integrate it to find out the tension. Anyway, T, and this side also it will be T, so effectively it's going to be like 2T cos theta in the upward direction, and in the downward direction it's going to be root 2 mg. It should be the case. What have they asked? They have asked the value of theta. I don't think it should be a difficult question anyway. 2T cos theta should be equal to root 2 mg. Okay, one more thing. In the question they have given root 2 m. Remember, you should understand that this is a misprint because mass, if will come out in the root, then there will be kg inverse, kg to the power half. That means the unit of mass will also become kg to the power half, which is not possible. So m cannot be in the root, only root 2 is in the root, not root 2 m, the whole. This is some mistake over there. Root 2 mg, and t is nothing but mg from this particular mass. So I can say that 2 mg cos theta is nothing but root 2 mg. mg is going to cancel out, and I'm going to get that cos theta is nothing but root 2 by 2, which eventually turns out to be 1 over root 2, and which is the angle that's 45 degree. This should be the result. Yeah. What is the maximum value of the force F such that the block shown in the figure does not move? Okay. Here, one important thing we should understand, that there is a force F being applied in this direction, and because of this force there will be one component in the horizontal direction, but there will be one component in the vertical direction, and this component will push the ground, due to which the reaction, the normal reaction effectively will increase, and this normal reaction is going to add up in the friction. So we need to consider all the situations here. This force, the only force which is responsible for this to move, is nothing but F cos theta, which is 60, and F sin theta is nothing but in the downward direction. There will be root 3g in the downward direction, that is mg, nothing, and there will be normal reaction. So the normal reaction will come out to be root 3g plus F sin theta, which I don't know what it is. F sin 60 is nothing but root 3 by 2, so F root 3 by 2, this is n. And the frictional force will come out to be the maximum frictional force, because they have asked the maximum value of the force. So friction will act at its maximum, like act as its verge to find out the value to stop the particular body. So friction will come out to be mu, that is 1 over 2 root 3 times n, or root 3g plus F root 3 by 2. This is the maximum friction force. And the only force which is responsible for the body to move in the forward direction is F cos theta. So I need to find out the maximum value of the force F such that the block shown in the figure does not move. If it does not move, that means F cos theta should just balance out 1 over 2 root 3g plus F root 3 by 2. Solve it out, you should get the value. Cos theta is cos 60, so cos 60 is nothing but half F by 2, minus if you multiply with this, it will be F by 4, so minus F by 4 is going to be G by 2, and it becomes F by 4 is nothing but G over 2, or F will come out to be as 20 if I consider G as 10, so it's gonna be 20 Newton. This should be the correct result. Here you just had to take care of this F, that there will be one normal component because of the F as well, F sin theta as well. Two masses equal to m are lying on the x-axis at minus a0 plus a0 respectively, as shown in the figure. They are connected by a light string. A force F is applied at the origin along the vertical direction. Okay, the situation is like this. We have two masses over here, 1 and 2, and they are connected by light spring. Okay, this is a light string, not spring. A force F is applied at the origin along vertical direction. ऊपर की तरफ there is a force being applied in the vertical direction. As a result, the masses move towards each other. Okay, obviously when we are moving this particular F, like it is tied. The string is tied to some particular another string, and I'm pulling that string. So in that case, these masses will start coming closer towards each other without losing contact with the ground. We are moving it very slowly, that it has not yet lost the contact with the ground. It is still with the ground. What is the acceleration of each mass? We need to find out the acceleration of each mass. Okay, let's consider the situation after some time. It's going to be somewhat like this. 1, 2, and it will be somewhat in this way. Yeah, it's gonna be somewhat in this direction and somewhat in this manner. And this coordinate they have given as minus x comma 0 and plus x comma 0. Initially they were at minus a comma 0 and plus a comma 0. So obviously x is less than a, that's for sure, because now they have come closer. A must be somewhere here. But the length of the string, because right now it is 2a, so effectively this length of the string is nothing but a only. This is a. Anyway, and this is x, so this is going to be root over a square minus x square. Okay, we'll see how we're going to use that. Let's assume this angle to be some theta, and we need to find out the acceleration. So for that we need to find out first the force on the particular object. If we consider the force, like if we mark this particular point, then we have one tension in this direction, another tension will be same here, or I can say that t cos theta. So 2t cos theta will nothing but balance f, and that means it will be equal to f in this situation, because this point 2t cos theta is equals to f at this point. So effectively t will come out to be f over 2 cos theta. This is the tension. Cool. Now this tension is nothing but the force which is responsible for the movement of this body, but this force is not moving this particular body in this direction. A component of tension is moving this particular body in the horizontal direction, because the body is not moving in the direction of t, it is moving in the horizontal direction. So if t is acting in this direction, we should take a component of t in this particular direction, which is nothing but t sine theta, if this is theta. So this is going to be t sine theta. And now t sine theta is responsible for the movement of the mass, or I can say that t sine theta is nothing but mass times of acceleration. So acceleration will come out to be t sine theta over m. We have t, so acceleration will come out to be f over 2 cos theta sine theta by m. Okay, this is going to be tan theta, and tan theta from the triangle, if I say perpendicular upon base, so that means x over root a square minus x square. So effectively I'll get f over 2 m x over root a square minus x square. This is the correct option, seems like this. Yeah. So here you just had to take care of that fact that the object is not moving in the direction of t, it is just moving horizontally. So we need to take a component of t. Moving further, a block of mass m is an inclined plane of angle theta. The coefficient of friction between the block and the plane is mu, and tan theta is more than mu. Okay, if tan theta is more than mu, tan theta is equal to mu is the condition of repose. That means right now, when mu is equal to tan theta, that means body is at the verge of its motion. That means friction is at maximum point. When tan theta is more than mu, that means the object will surely move down in that condition. The block is held stationary by applying a force P. See, that's why they have applied a force P to hold the block. They have applied some particular force P to hold the block. Held stationary by applying a force P parallel to the plane, the direction of the force pointing up the plane is taken as positive. The direction, this side is positive and the opposite side must be taken as negative. As P is varied from P1 is equals to mg sin theta minus mu cos theta to P2 is equals to mg sin theta plus mu cos theta, the frictional force F versus P graph will look like. Okay, now try to understand. This is the present situation when the object, we have applied some force, and that force, okay, let's assume it without P, with some first. In the downward direction there will be mg, That means in this direction there will be mg sine theta, and in this direction there will be frictional force which will be maximum like at mu mg cos theta, because normal will be balanced by mg cos theta anyway. So mu mg cos theta. For this body to move, and it will move, that mg sine theta will be more than mu mg cos theta, then only it will happen. So mg sine theta minus mu mg cos theta is the force with which mg sine theta minus mu mg cos theta is the force with which the body will start moving down. So to stop it, if we apply the same force mg sine theta minus mu mg cos theta in this direction, the body will be just at rest. The friction is still acting, mg sine theta is still acting, but we have applied, it's something like, say for example, the friction is 10 Newton, the mg sine theta is 15 Newton. So basically the body is coming down with 5 Newton, 15 minus 10. What we did, we just added a support of 5 Newton in this direction. So basically it is just balancing out, and we gave it. P1 is, if you look at it, P1 is exactly this, mg sine theta minus mu mg cos theta. This is the value. Mg sine theta minus mu mg cos theta, this is the value of P1. Now what happened, I started increasing the value of P1. That means I started increasing the value of my force. So it was something like this, I imagined as 10, sorry, in the downward direction it was 15, it was just a consideration. The maximum value of friction is 10, which is right now. So the body is moving down with some force 5. So I applied a force P1 which is equal to 5. Now what I did, I started increasing the value of 5. I made it 6. So when I made it 6, now what exactly is the situation? Now friction does not have to apply its maximum extent. I have given some support to it. So basically 9. Friction will start working as 9, because 9 plus 6 is 15, and the downward force which is responsible for the body to move down is nothing but 15. So 15 should balance out 15. So if I have started increasing my force, then what will happen? The frictional force will start coming down. There will be a time when frictional force will become 0, and I will just hold the body, means 15 downwards, so I will just apply 15. If you see, it is going from mg sine theta minus mu cos theta to mg sine theta plus mu cos theta. That means it is going to increase. Mg sine theta minus mu cos theta, from here it will become mg sine theta, finally it will become mg sine theta plus mu cos theta. So what I am doing, I have started increasing the force. So when I have started increasing the force, the value of friction will decrease, but it is still in the positive direction. Positive direction, this can be a case. Positive direction, this can be a case. It cannot be a case. It cannot be a case. Coming on these two. Now what happened? I continuously increase the force 15. Now this 15 is balancing 15 down. My force is also 15. It is also 15. That time friction does not need to work. So in that case, at this point, friction is 0. Here friction is not becoming 0. So our answer is out. It should be A. Anyway, considering further, if I apply the force further, in that situation, I am basically trying to move the body up. I am applying a force of 20 in the downward direction. There is a force of 15. So the body will start moving up with the force of 5. So in that case, friction will start acting in the opposite direction to stop me, so that I am not able to move the body. Friction will act in the opposite direction. Friction can go maximum till 10, as I considered here. So basically, as I keep on increasing my force 20, 21, 22, friction will keep on increasing, but in the opposite direction. And there will be a time when friction will give up and my force will increase. So effectively it will go like P1 to P2. And P2 is mg sine theta plus mu cos theta. This is that maximum value when the friction is at its maximum, but in the opposite direction. So it is a particular curve. This is a qualitative analysis, and it's a nice question. A ball of mass m, 0.5 kg, is lashed to the end of a string of halving length this. The ball is rotated on a horizontal circular path about vertical axis. The maximum tension about the string can bear is 324 Newton, the maximum value. Okay, we have a string, and we are rotating this particular string in some sort of a horizontal manner. And the maximum tension the string can bear is 324 Newton. So the maximum value of angular velocity, they are asking like what should be the maximum value of angular velocity, how fast I can move it horizontally so that the string does not break, I think. Yeah, so let's assume this angle to be theta. So there will be L cos theta, and this is going to be L sin theta. And this is the radius at which it is being rotated. So if I consider the situation, here is what we have T. In the downward direction we have mg. In the upward direction it's going to be T cos theta. In this direction it's going to be t sine theta. So t sine theta is being balanced by mv square by r, because the force that will be there, that will be mv square by r, or v can be written as like r omega. So effectively it's going to be mr omega square. Mv square by r, v can be written as r square omega square, so 1 hour it cancel out, m omega square r. This should be the case, and m omega square r is nothing but L sine theta, and this is t sine theta. So t should balance out, means sine theta should cancel out. And okay, tension can have maximum value of 324. So at that time, what should be the maximum value of omega square? We need to find out that. So omega square cannot be greater than t by ml, or I can say that root t by ml should be the value of omega. Do we know t? No, we don't know t, but we can find out t using t cos theta is equals to mg. Can be? Yeah. So t cos theta is going to be mg. What else we know? We know the mass, we know the length, we don't know t. T cos theta is equals to mg, and from here we get t is equals to mg by cos theta. If we put it here, do we have theta? Vertical axis, t sine theta is balancing this, t cos theta should balance out this. Okay, m omega square L mg by cos theta. If I put it here, it's going to be under root mg by cos theta ml. M to m cancel, g by cos theta L. G by L cos theta, and L cos theta is nothing but this is L. L cos theta is nothing but this. But what do I do with this? Having length 0.5, mass 0.5, I know mass, but I don't know the angle. Okay, let's think it in a different manner. T sine theta is going to be m omega square r, and t cos theta is going to be mg. If I divide both of these, I get tan theta is equals to omega square r by g. Okay. From here, I don't know the value of t, and I can find it out as, I don't know theta again. Okay, come back to this again. Mass I have, L I have, the maximum tension I have. T sine theta is equals to m omega square r. This is perfect. Sine theta will get cancelled out. Okay. T by m. Okay, fine. We did it here only. The tension we know as 324, the maximum value. Mass we know, L we know. If we put the value, we should get the result. It's like 324 divided over like mass, which is 0.5, and length, which is also 0.5. So effectively it becomes 0.25. That becomes 25. It goes up 100, and from here I think we should get omega. Omega should be less than equal to root 324 into 100 divided by 25. So it should come out to be like 4. 324, it's like 2, and 324 is the root of, is the square of 18. So effectively it's going to be 18 into 2, it's going to be 36. It should be the correct result. How did I come to know it's at 18? Because 20 is 400, so it should be less than that, right? So accordingly it should be equal, and 18, 8 8 is 64, so it goes that way. It should be like 36. Okay, this was a waste of time. We should have got it here only. So anyway, moving further, a block of mass m1 equal to 1 kg and another mass m2 equal to 2 kg are placed together on an inclined plane with angle of inclination theta. Okay, there are two blocks attached together and placed on an inclined plane. Various values of theta are given in list 1. The coefficient of friction between the block m1 and the plane is always 0. Okay. The coefficient of static and dynamic friction between the block m2 and the plane are equal to 0.3. Okay. That means there is a friction here, but there is no friction here. this is a frictionless thing. In list 2, expressions for the friction mu equal to 0.3 it is given. In list 2, expressions for the friction on the block M2 are given. Match the correct expression of the friction in list 2 with the angles given in list 1 and choose the correct option. Okay, what's the question is saying? In first case, we have some angles given, that is the angle of the inclination, and in the second case, some values of friction are given. And the question is asking here, like, how will the friction vary or depend according to the movement here? Okay, so if we consider what is the maximum value, like when it will come down, so the force with which it will come down is nothing but m1 plus m2 g sine theta. It is the force with which it's going to come down, and this should be balanced. This should be the friction force if it is in the condition of rest. So this should be balanced, or I can say that this value, which is going to be mu m2g cos theta. Why I'm considering it as mu m2g? Because the friction is only there in the m2, I mean on this particular part, and not on this particular part. So this normal is nothing but going to be m2g cos theta. So m2g cos theta. So for the body to not move, for the body to be in rest, mu m2g cos theta should always be greater than or equal to m1 plus m2 g sine theta. It should be a condition. Okay. Now, if I take mu, which is given to me as 0.3, m2, which is 2, that is 20 into cos theta, should be greater than or equal to m1 plus m2, which is 3, 30 sine theta. So if I check it out here, 0.3 into 20, it comes out to be 6 cos theta should be greater than or equal to 30 sine theta, or eventually comes out to be tan theta should be less than or equal to 1 over 5, which is nothing but less than or equal to 0.2. If you check here, tan 5.5 is 0.1, tan 11.5 is 0.2. That means this is 0.2, tan theta is equals to 0.2. That means for whatever value tan theta is equals to 0.2, the angle which is lesser than this, in that case the body can remain, body will be in the static condition. That means for theta is equals to 5 degree and for theta is equals to 10 degree, the body is going to be at rest. And when the body is going to be at rest, in that case friction is not required this much. The friction will be just balancing m1 plus m2g sine theta. So that means the frictional force is going to be m1 plus m2g sine theta. m1 plus m2g sine theta. That means for P and Q, the frictional force is going to be m1 plus m2g sine theta. For P and Q, it's going to be 2. P1, no. P2, Q2, this can be an option. P2, Q2, this can be an option. P2, Q2, this can be an option. Okay, now A is rejected. I have B, C, D. These are the options. Further, for any further angle like 15 and 20, till 0.2 it will be at rest. After that it will start moving. So when it will start moving, the friction can give whatever it can give, like the maximum value. So in that case the friction, whatever angle after that, the friction will give mu m2g cos theta. And in that situation, theta equal to 15, that is more than 11.5, and theta is equals to 20. In both these cases the friction will be acting as maximum, because static and dynamic coefficient of friction are same. Normally they are a little different, but anyway they have given it as same. So it's going to be mu m2g cos theta. That's it. So for R and S, the maximum friction which can act is number 3. And for R and S number 3, this should be the correct result. So the option is T. You just had to look about, they had given the angle of tan. So you just had to take care of that where exactly the body will start moving. It will start moving at the value tan theta. Whenever the value of tan theta will become more than 0.2, that means after 11.5 degree. If there would have been another option 11 degree, then also the frictional force would have been same. That is m1 plus m2g sine theta. But for 12 degree, it's going to change. It's going to be the maximum value of the friction which can be applied. A small block of mass 0.1 kg lies on a fixed inclined plane PQ, which makes an angle. How many questions are left? Okay, cool. A small block of mass 1 kg lies on a fixed inclined plane PQ, which makes an angle theta with the horizontal. Okay, the horizontal force 1 Newton acts on the block through its center of mass as shown. The block remains stationary if. We'll have to check all the options. If we look here, if we apply 1 Newton is the force, let's make a normal. This is the condition, and we have 1 Newton force over here, we have an mg in the downward direction, and what else, like if this is theta, this normally used to be theta, this is theta, so this is also going to be theta. So there will be one force acting in this direction, which is not even required actually. A small block of mass 0.1 kg lies on a fixed inclined plane PQ, which makes an angle theta with the horizontal force of 1 Newton acts on the block through its center of mass as shown in the figure. The block remains stationary if the block will come down because of the force, which is somewhere here, that if I take the component of this, if I take the component of mg, in that case it is going to come down with the force of mg sine theta, and this side will be mg cos theta. There will be a normal reaction. If then what can stop this? So this can stop this. There will be a force which will act in this direction, which will be the component of this, that will be 1 cos theta, because the force is 1 Newton, and this is going to balance mg sine theta. Then only the body is not going to move. So if cos theta is equals to mg sine theta, the mass is given as 0.1, so 0.1 into 10 into sine theta, so that means cos theta is equals to sine theta. In that case the block will not move. That means theta is equal to 45 degree, the block is not going to move. So theta is equals to 45 degree, the block remains stationary. I have considered a situation where there is no friction. Here they have not mentioned anything about the friction. That means here at this point they will balance out and the body will remain at rest. If I consider another case, theta is more than 45. When theta will be more than 45, in that case the body will tend to slide down with the force of 1 Newton. So when theta is more than 45, this 1 Newton will not be sufficient to hold it. We need more. So we need some force in the upward direction which can hold it. So when theta is more than 45 and a friction force acts on the block towards P. When theta is more than 45 and the friction force acts in the block towards P. No, it is basically supporting mg sine theta. So not this. It cannot happen. When theta is greater than 45 and a friction force acts on the block towards Q. This can be a case because theta is greater than 45, the body is tending to slide down, so we need another support in the opposite direction so that the body doesn't come down, because mg sine theta now will be more when theta is more than 45. So 1 Newton will not be sufficient to hold this. We need another force. That frictional force will act towards the Q direction. So this can be a case. And theta is less than 45 and a friction force acts on the block towards Q. When theta is less than 45, in that case 1 Newton will be more than mg sine theta. So that means this 1 cos theta will be more than mg sine theta. So in that case the body will tend to move in the opposite direction. We need the body to be stationary. So in that case we need a frictional force towards P, not towards Q. So when theta is less than 45 and a friction force acts on the block towards Q, no. If it would have been P, it would have been a correct result. If it would have been Q, it would have been a correct result. But right now A and C is the correct result. This is the last question. A block is moving on an inclined plane making an angle 45 degree with the horizontal, and the coefficient of friction is mu. Okay, there's an inclined plane and the block is moving this time and the angle is 45 with the horizontal, and the coefficient of friction is mu. The force required to just push it up the inclined plane is 3 times the force required to just prevent it from sliding. Okay, if you consider that mg in the downward direction, there will be mg sine theta, and in this if I assume initially, that will be mg cos theta times mu mg cos theta. That is the friction force, maximum value I am considering. So if the block is sliding down, that means the force required to just push it up the inclined plane is 3 times the force required to just prevent it from sliding down. To prevent it from sliding down, we need the force mg sine theta minus mu mg cos theta. This is for the prevention. Let it be force F1. And to just slide it up, then mg cos theta mu will also act in the downward direction only. Both the force will add up because friction will move in the opposite direction now, because we are trying to push the object up. So in that situation, it's going to be mg sine theta plus mu mg cos theta is going to be F2. That is the force. And they have said the force required to just push it up the inclined plane is 3 times the force required to just prevent it. So effectively 3 times of F1 is nothing but F2. Solve it. It's going to be 3 times of F1, that is 3 mg sine theta. Mg is, mass is not given, okay, 3 mg sine theta minus 3 mu mg cos theta is going to be mg sine theta plus mu mg cos theta. Mg will get cancelled out. Okay, that's why M is not given. Mu we don't have, and we need to find angle we have. So 3 by root 2 because sine 45 minus 3 mu by root 2 again equal to 1 by root 2 plus mu by root 2. Root 2 again will get cancelled out, will become common and cancel out. So 3 minus 1 is gonna be 2 and 4 mu. So mu will come out to be 2 by 4, eventually half. If we define n is equals to 10 mu, then n is, if n is equals to 10 mu, then 10 into half, so n is 5. This is an integer type. IIT introduced it, I think, in 2009 or 2010. But yeah, this is an integer type. Answer can be anything from 0 to 9. So n is equals to 5. This is the correct result. Okay, this was the 5th day. That means we discussed the question of laws of motion, some previous year problems. I tried to cover like almost all types, with friction, without friction, pulley mass system, etc. If you like it, please share it if you think it can help somebody. Thanks a lot for watching. Have a good day. Bye-bye.